Imagine a planet hurtling through the vast emptiness of space, untethered from the warmth and light of a star. This is a rogue planet, a celestial nomad cast adrift from its solar system. It wanders the cosmos in perpetual darkness, its surface locked in a deep freeze. Life on such a planet would be incredibly challenging. It would demand remarkable resilience and ingenuity from any species hoping to survive. The absence of a sun presents the most significant hurdle. Sunlight is our planet's primary energy source, driving photosynthesis and regulating our climate. Without it, a rogue planet would be a frigid, desolate world. Temperatures could plummet to hundreds of degrees below freezing. Survival on a rogue planet would necessitate adapting to a subterranean existence. Deep beneath the frozen surface, geothermal energy could provide a source of heat. This internal heat, radiating from the planet's core, could offer a refuge from the lethal chill of the surface. The challenges of a rogue planet are daunting, pushing the limits of our understanding of life's tenacity. Yet, the possibility of such a world, harboring life in the most unexpected of places, is a captivating thought. It begs the question, could we, as a species, ever adapt to such an alien and unforgiving environment? The perpetual darkness of a rogue planet would be more than just disorienting, it would be life-threatening. Without sunlight, plants, the foundation of most ecosystems, would be unable to photosynthesize. This would necessitate the creation of artificial environments where light could be carefully controlled and replicated. Deep underground, humans would need to engineer a substitute for the sun's life-giving rays. Vast caverns would have to be illuminated with powerful artificial light sources. These would need to mimic the spectrum of sunlight to support plant growth for food and oxygen production. Heat would be another critical concern. Geothermal energy, harnessed from the planet's internal heat, could provide a sustainable solution. Geothermal power plants could generate electricity and heat, powering underground cities and cultivating crops in vast underground farms. Nuclear power could also play a crucial role. Compact, self-contained reactors, perhaps utilizing next-generation thorium technology, could offer a long-term, reliable energy source. This would free humanity from relying solely on geothermal vents, which can be unpredictable and geographically limited. The unforgiving surface conditions of a rogue planet would necessitate a complete shift in our understanding of habitation. Forget sprawling cities and open skies. Our future would lie in the embrace of the planet's interior. Massive, self-sufficient underground complexes would become the norm. These subterranean cities would need to be marvels of engineering and resourcefulness. They would have to be entirely self-contained, with robust life support systems to maintain a breathable atmosphere, manage waste, and recycle water. Oxygen, crucial for human survival, would be carefully managed and recycled within the sealed environments. Advanced filtration systems would constantly purify the air, removing carbon dioxide and other contaminants while replenishing oxygen levels. Food production would rely on hydroponic and aeroponic farming techniques. These methods, requiring less space and water than traditional agriculture, would allow for the efficient cultivation of crops under controlled conditions, independent of sunlight and surface weather. Water, the elixir of life, would be a precious commodity on a rogue planet. While the frozen surface might offer vast reserves of ice, accessing and melting it would require significant energy. Therefore, efficient water recycling and conservation would be paramount. Closed-loop systems would need to be implemented to capture, purify, and reuse water within the underground habitats. Every drop would be precious, from wastewater to condensation, ensuring the continuous sustenance of the population and their food production systems. The lack of a natural day-night cycle could disrupt the human circadian rhythm, potentially impacting sleep, mood, and overall health. To counter this, artificial day-night cycles would need to be established within the underground cities, regulating light exposure to maintain a semblance of normalcy. The diminished gravity of a planet smaller than Earth could also pose challenges, potentially leading to muscle and bone density loss over time. Countermeasures, such as artificial gravity environments or daily exercise regimens, would be crucial to mitigate these adverse effects.